The image of the sample holder shows Massbox's versatility for analysing multiple battery materials in each analytical session. Here's a set of 3 graphite anodes and 2 NMC cathodes. We'll look at the bottom graphite anode sample in greater detail to demonstrate Massbox's ability to identify and diagnose contaminant particles. So I'm going to zoom in here on the bottom sample. Here's the anode material I was talking about, and we have a raster that has been acquired on that sample. So I'm going to zoom in so you can see the map of the raster. This is currently depicting carbon. And since it's a carbon material, it's no surprise that we can see carbon evenly distributed throughout the sample. Now, we did deliberately contaminate this material with stainless steel particles. The stainless steel particles are primarily comprised of iron, chromium and nickel with an average particle size of 38 microns. So we first analysed the area in a large 1mm by 1mm raster with a 20 micron laser spot size. Now let's see what else is in there. So I'll click over here on the periodic table, select chromium, and then go back to the map, and we can see some bright spots. We're able to identify several hot spots of high chromium, which would indicate the presence of these stainless steel particles that we could deliberately contaminated the sample with. So to look at this further, we analysed the area with the high chromium in greater detail. So we used higher resolution, which means we used a smaller spot size of 15 microns. So now let me just enable that area and then hide the area that we just looked at. And then we'll switch on some elements. So let's switch on iron. And then we can zoom in. And so we have some areas of high iron concentration in addition to the chromium that we saw earlier. So this is definitely due to the deliberate contamination of the sample with the steel particles that we utilized. And here we have a bright spot for lithium in the sample in the bottom right. Let's see what else is present with that one. So again, let's go select manganese and come back into the spot. And look, we have manganese in the map just where we had the lithium. We can also switch on cobalt. And again, we see cobalt. So we've got lithium, nickel, manganese, and cobalt all present. So this indicates to us that this is an NMC cathode. So we've got some contaminant particles from the cathode materials on this anode. So a significant benefit of Massbox is its ability to detect all elements present without requiring the user to specify which elements they want to measure prior to starting the analysis. Although the objective of this study was to identify stainless steel contaminant particles, we also identified an unexpected NMC cathode particle on the sample. This study does highlight Massbox's proficiency in scanning millimeter scale areas of electrodes and pinpointing contaminant particles down to the micron scale, and effectively diagnosing their origins, all within less than 30 minutes. Although optical techniques can identify contaminant particles in electrode manufacturing, engineers cannot determine the origin of the contaminants without measuring their chemistries, and so this highlights a significant benefit of the Massbox.